Hello class, today we are talking about section 3.6, which discusses proportional and non-proportional relationships. By the end of the lesson, you'll be able to identify what a proportional relationship is and use that to write and solve equations. You will also be able to identify a non-proportional relationship and write equations for those. First up, a proportional relationship can be used to describe the equation y is equal to kx, where k does not equal 0. This should look very familiar to you because we also call these direct variation equations. So direct variation is the same thing as proportional, same thing, two different words, two different titles for it. The graph, again, passes through 0, 0. And the last thing we want to note is that the ratio of y over x is constant when x does not equal 0. So if we're looking at this graph and we would pick out this first point, it's 6 over 2, and that is equal to 3. We pick out another point, and we've got 12 over 4 is equal to 3, and if we pick out one of these on the negative side, we got negative 12 over negative 4 is equal to 3. So that ratio of y over x is constant. So part of our job is to figure out if a certain table is proportional or not. So the first thing we're going to want to do is put this on the graph. If we're looking at our x values, our number of students, those are going to fit on our graph. So we can just keep those as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 along the bottom. Going up the side, we have 45, 90, 135, 180, and 225. Right now, if we just counted by ones, those wouldn't work. Going up the sides, I'm going to choose to count by 45s. So we end up with 45, 90, 135, 180, 225, 225, excuse me, not 222, 270, 315, 360, 405, and 450. Putting that on the graph, our first point is at 145, 290, 3, 135, 4, 180, and 5, 225. As with any other graph, we are going to go ahead and connect it all the way through with our straight line and add our arrows onto the end. Now looking at the graph, it looks like it goes through 0, 0, so it appears to be a proportional relationship, but we want to double check that. So we want to check that y over x is constant. 45 divided by 1 is 45. 90 divided by 2 is 45. And if you kept checking all of those other points, it would give you an answer of 45. So yes, this is a proportional relationship. Given that information, we can now write out our equation. So knowing that we go up by 45 every time, we can plug in and say our k value, or our constant rate of change, is 45. And now that we've written our equation, we can use that to solve. If he is tutoring 8 students, we have 45 times 8, which gives us an answer of 360. Remember, since it is a word problem, you want to have that $sign as your label on your answer. Go ahead and try this one on your own, first proving if it is proportional or not, and then answering the 2 questions below. It is a proportional relationship, which means your equation ends up being y is equal to 12.5x, giving you the cost of 10 pizzas being $125. If you have questions about that, let me know when you get to class. The other type of relationship that we're looking at is the non-proportional relationships. These are the linear graphs that do not go through 0, 0. So if we're looking up top here, 0, 0 does not touch the line. Another way to indicate this is the ratio of y over x is not constant. So looking at this first point, I have 9 over 1, which is equal to 9. Our second point is 12 over 2, which is equal to 6. So we can already see that our ratio is not constant. So how do we write an equation when we have something that is not direct variation or proportional relationship? You still need to be able to find a way to get from point to point. So first we need to pick out some points. I'm going to pick out this one right here and this one right here. You need to have 2 points in order to be able to find the slope, which is going to help you write the rest of the equation. So my first point that I picked out is at 1, negative 2, and my second point that I picked out is at 2, 0. That gives me an x1 and a y1 and an x2 and a y2. We can use that to figure out the slope. So I've got 0 minus negative 2 over 2 minus 1, which turns into a slope of 2 over 1. Just like with direct variation or proportional relationships, that's going to start our equation as our k value, or being multiplied with x. If this was the case right now and we just said y is equal to 2x, when I plugged in 0, I would get an answer of 0. But that is not what I want. When I plug 0 for x into my equation, I want to be down here at negative 4. So plugging in 0, I would get y is equal to 2 times 0. And I want that answer to equal negative 4. So I have to tack that negative 4 onto the end of the equation. So when there is a non-proportional relationship, it starts the same as the proportional equation, but there's going to be something added or subtracted on the end, on the end to change where that starting point is at. Go ahead and try this one on your own. Picking out a couple of points, you should have ended up with a slope of 3/4, so that k value of 3/4. Our starting point is up 3 this time, so I have the plus 3 at the end. If you have questions about this or anything else from the lesson, please let me know when you get to class.